Hey, pre-calc class. I'm just gonna make a quick video here of a few little tips and tricks to help you write some trig equations. All we've done so far is take it from equation to a graph. So what happens if we want to sort of reverse that? And this will help us lead into applying some of these trigonometric functions, which we'll do a little bit of today, but mostly on the next class. So for today, watch this quick video. There's a Desmos activity for you to try. It's only 12 screens, so I think you'll fly through it pretty quickly. And then there's a few practice questions to look at. So there's no quiz today, just submitting the Desmos activity and your 4 questions will get you the 5 points for today. So I want to start by looking at a situation where you're given a graph, okay? And think about we're going to write this function, assuming it's a trig function, and here cosine and sine functions, remember, are really closely linked. They're the same curve, one just starts in a different place than the other. So when you're writing these equations, you can choose which one you want to write. You'll just have to use a phase shift or a horizontal shift to go from a sine to a cosine function. So for our purposes right now, I'm just going to write this as a sine function, but again, you could also write it as a cosine function. So let's recall our transformation form. A sine b x minus c plus d, right? Those are the 4 components that we have to figure out. Oops. We need the a value, the b value, the c value, and the d value, okay? And so let's first look at number 1 is asking the vertical displacement, which would be d. Actually, let me color coordinate this here. Love some color coordination. All right, so we're looking for the vertical displacement. D stands for displacement. That's helpful. Well, when I look at this graph here, I'm looking at the top, which is at 1, and the bottom is at -5, right? So if I think about the distance between these, there is a total distance of 6 units from the bottom of the function to the top of the function, okay? So if we were asked what's the range of this function, well, then you would say it goes from -5 to 1, or we could write it -5 up to 1, right? The midline has to be in the center, directly in the middle of those 2 values. So if the total distance between them is 6, halfway or half of that distance is 3 spaces. So I'm going to come down from the top 1, 2, 3 spaces, or you could come up from the bottom 1, 2, 3 spaces. And so this line here, that is your midline, right? Well, what that tells us is that the center of my graph is not at 0. It's not on the x-axis. It's been shifted down to -2. So the midline, or the vertical displacement, should always be the average of the 2 values that you have, right? So find the middle. So our vertical displacement is down 2 spaces. That is D. What we also just figured out is in part 3, let's go yellow here, is the amplitude, right? Because if this total distance is 6, then the amplitude is half of that, or 3 spaces. So I know that the amplitude here is 3, okay? Now let's talk about okay, let's talk about the period. Sorry, I was just deciding whether or not to use the phase shift or not. So we want to look for a period. So I'm going to get rid of some of these other colors so that we can see that a little more clearly. So remember, when you're looking at for a periodic function, pick any place to start on the graph. So let's say, start up at +1. Now this graph goes down and comes back up to the same spot and it's back at positive 1 when x is 2 pi. Okay, so that tells us that our period is 2 pi. So period here, we're going to be looking for this b value. Period is 2 pi. Remember that your period is equal to 2 pi over b, because it's not actually the period that goes into your equation, it's the b value. So if we have a function where the period is something other than 2 pi, we might have to do a little detective work. In this case, our period is 2 pi, so if 2 pi is equal to 2 pi over b, well, I could cross multiply. I mean, it's kind of obvious to see, but 2 pi is equal to 2 pi b. To solve for b, divide by 2 pi, and b is equal to 1, right? So we know that when there's a 1 in front of the x, or when we don't see anything, that our period is 2 pi. So we had to reverse that a little bit here. So the b value is equal to 1. Really quickly, let's say our period was equal to 6. All right, well then 6 would be equal to 2 pi over b. Cross multiply, 6b is equal to 2 pi, divide by 6. So b would be equal to pi over 3. Now I'm totally just making up that the period's equal to 6. I just want to show you what it looks like when the value is not 2 pi, when the period isn't 2 pi. This is the number you'd have to put into your equation. So sine pi over 3x would be your equation to get a period of 6. All right. So just keep that in mind. Anytime you're given a period and you want to find the value that goes into your equation, you have to do 2 pi over b. Now, the key piece here that it's telling us is that we're assuming the graph has no phase shift, okay? So that being said, if the graph has no phase shift, here is my midline. Would it be a cosine or a sine graph that starts at the top of your amplitude? Well, that would have to be a cosine graph, right? And it's saying, is there a reflection in the x-axis? That, again, would come from the a value, right? So if there is a reflection, then this cosine graph would actually start down at -5, but it doesn't. It starts at the top. So there's no reflection, so I don't need a negative value in front. So if we were going to write the equation of our graph, we have the amplitude, 3. There's no reflection, so it doesn't have to be negative. We said it was the cosine graph. The b value is 1. There's no phase shift, so I don't have a c value here. And then the vertical displacement was -2, which I could put on the end. Okay? Let's change that rule, though, for number 5 for a second and say we didn't care if there was a phase shift. There could be a phase shift, right? Let's say I want to write a sine function for this. The amplitude is still the same, but I'm going to start with sine, and let's say my sine curve, get rid of that. Let's say this sine curve, well, remember sine always starts in the center, so there's a couple options you have. You could go back to pi over 2, negative pi over 2, and there's a sine curve. Okay, that's one situation. Or we could go forward to positive pi over 2, and there's a sine curve, but it's been reflected, right? Or you could even start it all the way over at 3 pi over 2. You can really start it anywhere, so you can write an infinite amount of equations for the same graph. I am going to kick it back to negative pi over 2 just because I don't have a reflection then. The period is still 2 pi, so everything else is the same, but now I'm writing a sine equation. So the b value is 1 because the period's 2 pi, but then because I shifted it to the left, pi over 2, I need x plus pi over 2 in my equation. Vertical displacement is still a -2. Okay, so that's one way that you can write the same equation, or sorry, the same function graph in multiple equations. And really, there's an infinite number of equations. Okay. One other thing I wanted to bring to your attention is that sometimes when people write trig functions, they put the midline at the beginning. So don't get tricked that this is really saying 80, because this 20 is connected to the cosine function. So writing something like that would be the same as saying negative 20 cosine 2 pi t plus 100. All right, just moving that to the end. Same exact thing. So if you're trying to match the graph, okay, this is a person's blood pressure. Well, look for the midline. The top is at 120, the bottom is at 80, so the middle is at 100. So that rules out C. The middle is not 120, right? Next, look at your amplitude. So it goes from 100 to 120, or from 80 to 100. So there's a difference of 20 there. Okay, so they all have an amplitude of 20. They all have the same period. So all the b values are the same. But let's figure out from this function here, from 0, if it's starting at the top of the amplitude, right, going down and coming back up, well, that's a cosine function, right? So we have 100 plus 20, and it's positive, it's not negative, it hasn't been reflected, cosine 2 pi t, right? So that would be the one that we want. The minus 20 cosine of 2 pi t would mean that this graph started here, went up and came back down. The negative sign would mean that it started here, went down, and back up. Oops. Oh, it's not writing. There we go. So when you're matching up the equation to a graph, you could have the midline at the very end there. All right. Thinking about, again, your range, this is a circuit has an alternating voltage of 80 volts that peak every 0.25 seconds. Use the graph below to write a sine function that models the voltage as a function of time. Well, let's, again, find those pieces. What's the midline, right? Well, looks like the bottom is negative 80. The top is positive 80. Then the midline is 0. Okay, it says to write a sine function, and it's starting at 0 and going up and back down, so that all looks fine. So the sine function doesn't need a phase shift. Then we want to think about amplitude. So if it starts at 0, goes up to 80, and then back down to negative 80, then the amplitude has to be 80, half the total distance of the graph. And then the period, remember, is 2 pi over b. We're looking for the b value. Well, to find the period, we want to say, okay, where did this graph start? And where did it end, the cycle? Well, starting at 0, it goes up at 1/8, it reaches its maximum. Then at 2/8, it must reach the center. 3/8, it reaches the minimum. 4/8, it reaches back to the center. And so that would be one full period is 4/8. Well, we know that 4/8 is really 0.5, or 1/2 of a second. So if the period is 1/2, that's equal to 2 pi over b. I'm going to cross multiply. So b is equal to 4 pi. And that's the value that would go into my equation, right? So writing a sine function, the amplitude is 80. There wasn't a reflection, so no negative. Sine of 4 pi x, or I guess t, say of time. And then the midline was at 0, so I could have plus 0, but I don't really need that, right? So that's another way to write an equation from the graph, or given some information. And the last piece here, a lot of trig function is used in sound, okay? So periods and frequency, those are closely related. They're inverses of each other, actually. So if you read this here, the period represents the amount of time it takes to complete one cycle. The number of cycles per unit of time, so how often it travels in a certain unit of time, is the frequency. And they're reciprocals of each other, okay? So here it says, write an equation of the sine function that represents the initial behavior of the vibrations of the note G above middle C, having an amplitude of 0.015 and a frequency of 392 hertz. So if you're very musical at all, you probably know about middle C. The next class we're going to talk about writing equations for some of these types of sound waves. So they're saying that the frequency is 392 hertz. Well, the frequency is 1 over the period, right? So then the period is 1 over the frequency. So our period here has to be 1 over 392, okay? But remember that the period is equal to 2 pi over b. And that's what they're doing here. They use k instead of b just because it's an application, but you could use either. And then they cross multiplied. And you get b is equal to 784 pi, right? 2 pi times 392. So that's what has to go in your equation for the function. So to write our function, the amplitude was 0.015. It's a sine function. And 784 pi t, or x, that would give me the equation, okay? So frequency, period, those are closely related. Again, I'm just sort of giving you an overview of this so the next class we can apply it a little bit more. So try the dozens activity, try